Welcome my dear students. Today I will continue the second part of the chapter motion, and in the last video I have left you at the types of types of quantities. So today I will continue from the types of motion. See, there are different types of motions that we see in our life. See, some types of motion we are seeing like straight line motion. Now you will ask, sir, what is straight line motion? If any object is running on a path which is a straight line, for example, you are running on a track. So if it is straight, that will be the straight line path, or the train is running on a straight line path, car is running on a straight line path. But you might have seen the clock. So clock is running in a circular path. So there are circular motion also. Circular motion. Okay. Zigzag motion also there. Means there is no proper path following by the object. So here we will restrict ourselves to study about the straight line motion or rectilinear motion. So in this we have to go through about the type of motion that we have to go through. So we have seen, or we have to study, first one, uniform motion, and the second one, non-uniform motion. There are two words, one is uniform, one is non-uniform. So keep in mind, if equal distance are covered in equal interval of time, then that type of motion is said to be the uniform motion. For example, if there are 2 points on a straight line, A and B. In between there are 4 points which are equidistant. Equidistant means all are at equal distances, C, D, E. Here AC is equal to CD, equal to DE, equal to EB. So if AC equal to CD equal to D equal to EB is distance covered by an object, and suppose the time taken by every interval of distance is same, that is, suppose T second it is taken, T1 time, here also T1, here also T1, here also T1. So this will be the case of uniform motion, means equal distance is covered in equal interval of time. But on contrary, if any of this is being changed, means if we have equal interval of distances but the interval of time is being unequal, or in equal interval of time the distances covered are unequal, then we will have the non-uniform motion. So if we have unequal distance or non-equal distances in equal interval of time, means time is everywhere same but distance covered is different in equal interval of time, or vice versa also can be true, unequal time interval and equal distances, then that type of motion is said to be non-uniform motion. This type of motion will be called as non-uniform motion. Means here I have written T1, T2, T3. T1 only I have written, I will write T2, T3, T4. Where these all are not equal. T1 is not equal to T2, not equal to T3, not equal to T4. Means they are not being equal. So that type of motion will be called as non-uniform motion. Further, so generally we face this type of motion. non-uniform motion, because uniform motion is not followed every time in every situation. So if a non-uniform motion is existing, then there is one term, and that term I will discuss later. Before, let me explain something. Suppose there are two cities, city A and city B. They are being at a distance of suppose 100 kilometer, and one person wants to go from A to B. He wants to go from A to B. Now he has many options. He can go by bike, he can go by the car, he can go by the public transport, he can. Then if he goes by bike, so approximately he will take 2 hours to 2 to 3 hours. On an average, suppose 3 hours he takes. By car he is going, so he will be taking around 1.5 hours or 2 hours. By bus or train, approximately he may take 2 hours. So here you see distance is same, but different modes are giving a different interval of time. It means the variation in the distance is being dependent on time. So there is some changes in the time. Okay. So how this change can be related with the position. So there is one term, how the rate of change of motion is. Change of position. At which rate the time that being played for the changing of the position, or the rate that is being applied for the changing of the position, means from one position to another position, that will be called as speed. So this is distance variation with time. Now, all the time we cannot be at a fixed speed, as I have discussed about the uniform motion. We cannot be at the uniform motion always. Suppose you are traveling by car, so all the time your car is not having the speed of 100 kilometers or 80 kilometers or 60 kilometers. It is varying depending on the situation of the road and traffic. So here we cannot talk about the absolute speed. So we have to talk about average speed. The concept of average speed will be taken. So that is equal to total distance divided by total time taken or total time interval. How much time has been taken to cover that certain distance in different segments, and how much total time has been taken to cover that distance. Some example I take. Suppose you are going from a city A to B. So you cover the distances in certain fragments. Suppose you go from A to C, C to D, and then D to B. Here you take suppose 10 minutes, here you take 20 minutes, and here you take suppose 5 minutes, take 15 minutes. So total time interval we will add, and suppose here you have traveled around 10 kilometers, suppose here 15 kilometers and here 12 kilometers for example. Then total distance means 10 plus 15 plus 12 and divided by total time interval 10 plus 20 plus 15. The SI unit of speed is meter per second, and sometime you might have seen written like this. So this is nothing but the power raised to the abbreviation for the time, that is second, S. So meter per second is the SI unit of the speed. That will be true for the average speed also. So till now we have not discussed about the direction of the change of position of an object. But if the object is changing its position in particular direction, so there, as I have discussed in the previous video, you can watch there if you have not watched, what is displacement, I have discussed there. So here, if the direction is being changed, the distance is being changed in particular direction, so here we will use the concept that is displacement. So instead of calling it distance, I will call it displacement. So displacement, you know. What is the displacement? Displacement means difference between the final position and the initial position. So that time the speed will be changing to velocity. So velocity means the rate of change of displacement. Keep in mind, what we will call rate of change of displacement with time. How the displacement is being changed with time. For example, you see, displacement was the final position minus initial position. Velocity if we write by v, so here we will write final position where the object is minus initial position where the object is starting, and upon total time interval, how much time it has taken. Correct? So velocity. It will also have the same SI unit. That velocity has, speed has meter per second. Correct? After this we have to study about graphs. But before going there, I'll discuss some questions of your textbook. So one question is there that I'm going to tell you that one question is there on page number 102. Page 102, and the question is, odometer of a vehicle reads 24 km at the start of the trip. This is the example 8.2 I am discussing. It is given, if the odometer of a car reads 2000 km at the start of a trip, means starting time, the distance covered was 2000 km. No problem. After 8 hours, it reads 2400 km. So how much distance it has covered? (2400 minus 2000), that is 400 km. Okay. So if it is 400 km, one segment we got. Second, they are saying if the trip took 8 hours, means time is 8 hours. You have to find the speed of car in kilometer per hour and meter per second. So see, speed is equal to, total distance upon time. How much time has been taken? So total distance, as we know here, 400 km divided by 8 hours. So it will be 50 km per hour. This is our first result. Second part, they are saying how much speed will be in meter per second. So here you see, as we are seeing, 50 km per hour. So kilometer means multiply by 1000, it will be changed to meter. And 1 hour means 60 into 60 second. 1 hour 60 minutes. 1 minute 60 seconds. 0 will divide this 0. 0. 0. And then 2 3 are 6. 2 5 are 10. And 2 3 are 6. 2 25. So you will get 125 by 9 meter per second. Meter per second and kilometer per hour. This will be your second result. Like the second you can also solve, and then after this the term comes, that is rate of change of velocity. So let us see what is the rate of change of velocity. See, if there is change in the position of an object, we get the concept of speed and velocity. And if there is any change possible for the velocity or speed, then what the term will be there. So suppose u be the initial velocity of an object, or you can say speed also, and v be the final velocity. Now before I go deeper in this difference topic, I'll tell you what is the meaning of initial velocity and final velocity. See, the time we are starting to count, at that moment what is the velocity we are seeing in the odometer, that will be the initial velocity. The time we stopped the stopwatch, that time velocity obtained is known as final velocity. So is there any change in the velocity also? It is yes. So rate of change of velocity or speed is represented by a term called acceleration. Now you might have seen the automobiles fitted with accelerator. So accelerator is doing the work of increasing the speed of the automobile as well as decreasing the speed. So that I'll tell you how it is increasing or decreasing. So if it is represented by a, small a, and this I have called final velocity minus initial velocity divided by time t. So this is known as acceleration, that is the rate of change of velocity. Further, it is not increasing the velocity all the time. So how it is increasing and how it is decreasing, let us see. If final velocity is greater than initial velocity, then we will get a value as positive. Why? Because v minus u will be some positive value. So here it will be acceleration. What do we call positive acceleration or simply acceleration? It will increase the speed. But the moment you are applying the brakes, so if final velocity is being less than initial velocity, that time it will be negative acceleration, or we call it, why? Because v minus u will be negative, so we will get deceleration or negative acceleration. Here the speed will be low. So what is the SI unit of acceleration? SI unit of acceleration is meter per second is the SI unit of velocity, and divided by second, that will be meter per second square. It is true for acceleration and deceleration both. So up to this video, this much only. If you have any confusion, you comment to me. Till then, stay happy, stay safe. Bye.